Our final video for this chapter will introduce entirely um, examples that we can work according to what we've learned in this chapter, and showing how the particle in the box illustrates the several of the postulates that we learned in the previous chapter. So when we get together in class, I want you to try to work these out on your own, but we will take a look at what we call a superposition function. This function is the sum of two possible particle in the box one-dimensional wave functions. And the question is this an acceptable wave function for the particle in the box? If so, is it an eigenfunction of the total energy operator, um, which we call the Hamiltonian? And if it is it normalized? And if it is not currently normalized, is it normalizable? Um, and show how we can normalize it. So we're going to work that out together in class. I'd like you to work on it on your own. That's how we'll show illustration for postulate number 1. For postulates 3 and 4, we want to talk about that same superposition wave function. What would the expectation value for energy be? And so we want to work that out as well. Our previously postulated solution for the particle in the box, which looked this way, is an eigenfunction of the Hamiltonian, but eigenfunctions of the Hamiltonian are not eigenfunctions of the operator um, x, not eigenfunctions of the position operator, and that's always the case. If something is, if we've got a function that's an eigenfunction of one of these two operators, it is not an eigenfunction of the other. So what is the probability of finding this particle in the central third of the box in its ground state? And what would that probability be for the classical particle? And again, these are all things that we're going to work out as examples in class, but I'd like for you to try them on your own as you have time. Postulates 3 and 4 will illustrate again by looking at whether this particular wave function is an eigenfunction of the position operator x, which we know it won't be because it's an eigenfunction of the Hamiltonian, but we want to show that mathematically and then calculate the expectation value of x. So again, we'll work all of these things out over the next few class periods as we meet together.